So, good evening, class. Welcome to the 10th week of the introduction to Python essentially. Today's class, I hope to go through a new library. Like the the last week was actually very brief in amount of new content it had. So, I feel like it's a good idea to look into one of the libraries that the week lectures touched upon. And honestly, the PIL library is incredibly powerful. So I thought we'll just dive into that first. Once again, if there are any questions regarding last week's lectures, feel free to ask. I will try my best to explain. And after going through the PIL thing, I thought we could write an algorithm to solve a maze. Like, you know, how there are mazes with walls and you must find the path through the maze into the other end. So I felt like that's a solvable question given the given knowledge we have right now. So, well, for the first thing, so for the first thing, we'll first naturally have to import the PIL library. Now, how do we know what is there in the PIL library? So, unlike So essentially, the easiest and quickest way to go through this is just to read the documentation. So when you Google PIL Python, it'll first show this, but you must try to take the link which is the official documentation, because in general the official documentation will be decent, good enough to get you into it. And apparently PIL is a Python image. Okay, it's pillow. We'll talk about forks later, but it's not really that important. And there are essentially several things it can do. Like they have given a lot of tools on how to do it. They suggest to do this for opening images, so let's do that. I have where did my so later during the class I think I'll be using NumPy also, so I'll just import NumPy here also as in. Now they said where did it go? Okay. So we can open an image like this. Now, if you are using this in a normal Python program, then you will have to do uh, mypic.show, and that will make a pop-up. But because we are on a Python notebook, all we have to do is just write mypic, and at the end of the thing, it will put an image of that here. So once again, I'm saying like interactive Python notebooks are just so good, and doing it in VS Code is even nicer. Just do everything in IPYNB. It's just, uh, anyways. So one thing we can do is like just go through and read each of these. But I personally just look at these and go, which is the nicer, more fun thing to do. So here they tell us we can cut, paste, and merge images. So maybe we can like take this eye and swap it to the other. That sounds like fun. So according to documentation, to copy an image, we need to specify a box. A box is a region defined by a fork tuple. I told you what a tuple is a couple of classes back. Essentially, it is a list of, a fixed list of four things. Now this might jewelry, I can explain the selenium stuff after this. Like I didn't, so I thought I'll go through pillow a little and then after the, yeah, I'll explain this after going to the pillow class. So to better understand this, we can look at essentially imagine this is a picture. Uh, I don't. Why can't you? Okay, imagine this is a picture. According to Pillow, according to Pillow, the region is defined by, this is the left upper place and this is the right lower place. That is, so if I want to have an image inside, how do I send this? Set backward, set backward. Okay. So imagine this is the box we want. If this is the box we want, this coordinate will have some 200 comma 200. This coordinate will be have 500 comma 400. Note one thing you have to notice is the top right, the top left is 0 comma 0. X-axis is obviously is always the horizontal axis, and even though these points are below the x-axis, we consider positive. So y-axis is in this direction, and how do I rotate you? Okay, and x-axis is in this direction. So if you want to take this region, we'll have to take, like, say 200 comma 200 and 500 comma 400. So we'll go back here. We'll say left I is equal to 200. Okay, before I say the actual values, to be honest, I don't know the size of the image, so we'll just get the size of the image first. So it's 730 in this direction and almost 500 in this. This region feels a little before, we'll say 350, I guess, or 250. And we'll just take a bigger region and crop it later. So so 250 comma 250 comma 350 comma 350. If I image is equal to m dot raw left type. Okay, I'm almost correct on the, okay, I'm neither correct on the x or y, so I'm so it has to go towards the left a little more. So 200, it doesn't have to be this wide. So 275. It has to go up a lot. So that is 150. That's almost right. I just have to take it a little wider. 325. So now I have extracted the left eye from the image. I can refine it a lot more. 220, 310. Yes. So what else can we do? So now we can essentially do any operation we want on this image, and left eye image dot rotate. Okay. So theoretically, oh no. Huh. Okay, so uh, one thing you have to learn is you should not do anything by yourself. Just read the documentation and do that. So, well, that worked, but we don't want this really. That's fine. We can just reload the image. But we can essentially do so much more. Like one of the things below is like we can apply filters. So we'll just include all the filters. So we can like blur the image. We can detail, I think, just increase the amount of detail in the image. Like you can see if the compression of the screen is not that bad, I guess you can see this is, I don't see any difference though. No, or not. Okay. Dot. So max filter, median filter, and all are all explained in the tutorials. So a max filter essentially will take the max bit in an small region of the image. Like a picture is essentially a collection of pixels. So Why is that? So if I take a large max pixel size, then it will in every block of 5 elements. Okay, if you have an image is made of multiple pixels. Now we can make lots of areas of lots of small squares in the image. So yeah, so like there'll be one small square here, one small square here, and so on. What max filter does is it takes all the big squares, all the small squares, and finds which is the biggest pixel in that. And by biggest, it usually means the one which is like brightest. So once it identifies the brightest, it will put that pixel throughout that square. So the white region here has clearly become much bigger here, and you can see the square also. If I can zoom in, dot save. Like you can clearly see the squares in all the images now. Like every 5x5 square will be, and now if I were to increase this to like 10, okay, 10 is bad, 6, 8, how do I, now it's clearly a blockier. Well, that's because we have taken a bigger thing. So those are things you can do. And in the class, we did a very long-winded way of taking the max, what's that thing called? Compressing the image. Because in short, Pillow has the ability to convert things. Give me a second. So every image will be of these kinds. It can every pixel can either be 1-bit, 8-bit, or RGB, and so on. So what Sir had done was taken the 8-bit pixels and convert them to 3-bit pixels. So instead of having done that, we could have used the modes available in the Pillow library itself instead of using NumPy to do the same. So that's the thing. So if I want to take my picture, I can easily convert it to my pic dot convert. So with I can like very easily convert between RGB and grayscale. And it's not just grayscale. There is essentially we also have types of pictures with a transparency mask. Like for example, right now in the video of me, it's like the video is capturing me and setting a transparency mask around me. I mean, so you can sometimes see the things pop up, but that's because it's captured it's not inside the transparency mask. Like this region here would normally not be captured, right? So what OBS is doing is it's taking a video of me, identifying me from the image, and then setting a transparency mask across. Because otherwise, if we don't put a transparency mask, it will be black around me, right? So a better example will be like if you try to save images. Yeah, yeah, you probably have seen certain images have the transparent background with the checkered box. PNG transparent background. So whenever checkered boxes are there, normally it's like a transparent background. So one better way to see it is, so there's a free online app called Photopea, and oh my god, I am not a robot. I cannot believe this. I can't believe I'm having difficulty in downloading an image. Huh, but this is a JPEG. Okay. Oh no, this is not going to work. Yeah, I'm very sorry. Okay, it's probably much easier for me to just code this in Python and code this in Python. Okay, anyways. So for example, like one one stupid thing we can do is take the, where did it go? So according to one of the commands here, yeah, according to one of the commands here, I can split the image into the, sorry, Kamal, I didn't see your question. While converting an image in black and white during enhancement, that sounds, I mean, Kamal, what do you think?
Sir, there was a discussion in our forum. Actually, some guys are telling if you convert to grayscale, it's not feasible to convert back to the color.
Yes, and
Two kind of discussions are going on. That's why I want to clarify my doubt. So if
okay,
you people help me, it will be great because you are working so much in image processing, no?
okay. So technically,
Thank you.
it depends on how you're converting it to black and white. In general, if you're going to be like, if you're converting a 3 RGB value, which is like a 3 8-bit pixels, to a normal grayscale, which is like 1 8-bit pixel, then you will lose information. This is because 3 8-bit
Sir,
pixels just has more information than 1 8-bit pixel.
sir, actually here they are not compressing, no? Enhancement. So enhancement means
You said converting from,
a question. See the question. So this is the NPTEL question, assignment eighth question. This is ninth question, which is available in week 8. During enhancement, actually, Vidya ma'am, I think
okay.
she explained how to convert a normal colored image to black and white through one method enhancement. Clay, I think we are
Oh,
having
Klahe,
built in.
yes.
Yeah, so using the technique she convert the given image to first convert to grayscale, then she did that enhancement. And that is the portion covered in the nptel video, and we had this question as the assessment while converting. So two kind of discussion is going on, so I want to know the answer. That's why I connected you, sir.
I have to look into Klahe again because technically,
Because
if you
here
have
they
a
have
black and
not
white
given
image,
class
you
and all.
have lost information. There is
Uh,
no saying that the information is just lost. You can't
mm,
get the same image back. You can get an
yeah.
approximation back, but it won't be the same image.
Yes,
It's something
yes.
like,
Mm.
but I have to read into Klahe to make sure that this is.
No, actually, here the question. Assume that this is the question posted in the
I would have
NPTEL
answered
final
false.
exam.
I would have answered false.
Yeah, this is what's a discussion going on there. Okay, fine. Thank you. I will take. Bye.
Okay, I'll look into Klahe because it doesn't make sense how.
No, sir.
Yeah.
No, sir. If you don't mind, I worked as assistant professor more than 16 years. Huh?
Okay.
Having, I handled this paper more than 4 times, Python and all. And I'm having some thorough knowledge in the basic Pythons. But
Yeah.
still, I
Okay.
need some more research-oriented idea. I switched to that course. But wherever we need the support, we expect you people to guide us, right? Uh,
Yeah.
okay, if you guide us in a proper direction, we will be it will be very beneficial for us and very thankful for you people also. Thank you, sir.
Yeah.
Thank you.
Okay.
Carry on. I am watching your video. Yeah.
Wait, are you dissatisfied with my answer?
No, 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 no.
Uh,
My argument is also your answer only.
okay. Okay. Good. Good. Like,
Yeah,
it
because we are
doesn't.
converting. Yeah, so I am actually too. I think they may also be a research scholar. They are talking about that grayscale, that elaboration. Because since we are converting, how actually whether we can that is regain the original color image, or
I.
I am getting only grayscale only. I am not able to see any colored portion and all in the conversion.
Yeah. So I'm fairly certain it's not possible. But
Because in
I
we
will
are
look
having.
into it though. I'll look into it
Yeah,
and
sure.
tell you next week. Like,
Yeah, sure, sure, sure.
like with a certain degree of confidence, I can say it's not possible. But as a
Yes, so
researcher,
actually, we are having one method also. I tried that method. Even I'm having in my system. So
like,
I applied that method and convert back that black and white to the color also. But I am
wait.
not getting the color. To some extent, also I am not getting color. I am getting another version of segmented black and white, not the.
Yeah, it doesn't
Mm,
like right now.
Mm-hmm.
I think the best way to get color back into images is to
Mm-hmm.
use some AI algorithm, because it's
Mm-hmm.
only after the AI algorithms came that we got stuff like painting in old pictures and things like that. It's not possible to.
Actually, this is the code, first part of the
Oh,
code she
CV.
used.
I
Uh,
cannot run. I can't import OpenCV2 in this PC, unfortunately.
okay, no issues. Just go this first set of codes, sir. The grayscale.
Yeah.
She used no create grayscale, and we are getting grayscale value and
Okay, give me a second.
enhanced
I'll
image.
just copy this because I'll run this in my other machine.
Okay, okay, and you
Oh,
can
yeah.
explain me in the next class.
Yeah, sure.
Yeah, next week. Thank you, sir.
Okay. Okay. Anyways. Oh, I completely out of track. Okay. Anyways. Yeah. It's not. It doesn't logically make sense. Okay. Doesn't matter. Okay. Okay. Now let's move on to. Oh yeah, I wanted to show about transparent sections. So according to the, what's that thing called? Yeah, according to Pillow, we can take an image and split it into its components. So the syntax is kind of simple. We'll just take this first, paste it here, and do something which is like, two. Okay, so what is this image doing? Oh, sorry, what is this code doing? First, it's taking my picture, which is which has red, green, and blue channels, and it's splitting it into red, green, and blue. For convenience sake, and for our, so that we don't have to memorize random things, we are saving R, G, B, and A are 0, 1, 2, and 3. Okay. So if I source is actually a list of pictures. So instead of taking, so I'll first take the first component of the source, and here I'm finding all the image, all the regions of the image where the red value is less. The Then I'm finding all the place in the image where the green value is. Okay, I must specify point also. So what the function point does, okay, I have not explained lambda functions. So okay, def temporary. So this is a very simple function. So if I, all this function does is take an input multiplied by 2. Super easy, right? But this is so much writing for such a simple function. I don't always want to write something so much. I don't want to write so much for something which is this small. So Python gives us the idea of lambda functions. Lambda functions has some mathematical basis and some, like there's something called lambda calculus, if I remember correctly. And essentially the idea is it's just a name for a function. So I can do temporary is equal to lambda. Lambda denotes the whatever I'm writing next is a one line function. So I'll write value. I forgot the syntax. Okay, value colon and value multiplied by 2. This is the same thing as this. If you're lazy, you will say that this is like much neater, but it's in the end just convenience. So I can do temporary 5 and it'll print 10 again. All I'm doing is defining a function in one line. The advantage of this kind of function is here I've not specified the name of the function. So this is sometimes also called anonymous functions because the name is not given. So what the function point does is applies a function to the image. Now this is similar to what I said last week. We can have functions that take functions, and this point is one such example. So the input of function is this function, which is okay. This function is easy to explain. So what this function does is, no matter where, this function just returns 0. That's it. Whatever the input, it returns 0. I will show another example. So okay, I have a black and white image. Okay. So right now I took this black and white image, and then whatever the input is, I replace it with 0. Because I replaced it with 0, every pixel is now black. Every pixel is now 0. If I want to make it like 255, every pixel will become white. I can give any value in between. So I can give x. I can't give x. Wait. Okay. X by 255 squared multiplied by 255. So that apparently has the effect of making the image less bright. Interesting. Okay. Okay. So essentially you can do all these things with point. Point essentially just takes, like, every pixel is a single number. So you can always apply a function on a number. And that's what it's doing. It's applying this function to all the numbers. Technically speaking, I can even go crazy and write, I can import numpy. Yeah, I already imported numpy. So np dot I can do np dot sine of x by 255 multiplied by 255. And that seems to have brightened the image. So that's interesting. So you can essentially do many things, many things you want using the point function. So what I did here is I set the value of g as green everywhere, 0 everywhere. Okay, a better example is, okay, so what I'm doing right now, I'll ignore a mask. Right now I'm taking the image, taking the green portion of the image, setting it to 0, and then like actually setting it to 0, and then I'm printing it. And you can see yeah, you can see that this image has no trace of green in it now. I can change it to whatever I want. So if I do this, oh, now the image has no reds in it, right? So I can do like kind of fascinating things. Like I can first take my pick enhanced is equal to my pick dot convert RGBA. now I split my pic enhanced. So I want the I don't need this. Source. So what I'm doing here is the transparency layer of the image, which is the which will be corresponding to A because RGB A. I'm instead of the old transparency layer, I'm setting it to the value of R at every point in the image. So that means if I run this, only the places with red will be bright. Every other part of the image will not be that bright. If I save this, temp2.save temp.png, where did it go? Where did it go? So I have saved it. You can see the checkerboard pattern, but to make it clearer, I will show it to you in Photopea. Yeah. So okay, yeah, it's a little scary, but you get the gist. Essentially, now this is like a very transparent image. Like the transparency scales based on the amount of red in the image. So that's why the red is very bright here and every other place is not that bright. So you can imagine how many things you can do with the PIL library. Like it's just you can do a lot of very casually fun things. So some other things I wanted to show. Yeah, so similar to what I had done here, I can selectively enhance portions of the image. So oh yeah, I should show that. Yeah, this was the black and white image. I can, using point, I can uh, just enhance the image in general. So lambda I multiplied by 2. So now it's just brighter. There are other image processing things, and you can work it out yourself. Like reading the tutorial here, there are many things you can do. This an image enhance module. I do not even know what all it can do. Yeah. Anyways, so that will kind of conclude my talking about Pillow. We can do a lot of things with Pillow. So I thought, why not we like make a maze in Pillow, okay? But before that, Jewelry, I will go through your question about Selenium right now. So did I do Selenium last week? Yes, I did. Okay. So Selenium is essentially a Python library for automating things on the internet. So one thing, the main thing you need is this Selenium import WebDriver. The driver is essentially what opens things up. So I'll just run these. So the moment I run this, it will open a Firefox window outside, and that Firefox window is programmatically controlled. Okay, so you know it's programmatically controlled because there's a robot sign here instead of the, where did it go? Instead of the normal things here. Anyways, so to open a site, once again, just like I open the documentation for Pillow, you should always have the documentation for Selenium also out. WebDriver is not opening string object. Give me a second. Could you show which command you ran? Like, what code did you send? Right. So, what code did you try running? Like, I would really recommend having doing something on VS Code or this thing which has autocomplete. So when I write WebDriver, I know everything inside WebDriver. What's a BlackBerry? Okay, it doesn't matter. So could you send me the code you ran, like how Kamala sent it a few minutes back? So just because this is automated doesn't mean you can't do anything. I can still open Mozilla.org and everything like that. Jewelry, are you writing your code here? Why is it so slow? Oh, okay, okay. So yeah. Anyway, so in addition, you can do normal Firefox things inside the automated browser, but you can Control Shift T. So, but you can also yeah. So if you want to open any any website, we can just do driver.get, enter the website. So right now I'm running this, and oh, oh yeah, we are just talking about this the other class that I can't uh, because this is an automated portal. It doesn't have access to my cookies, which is good for safety reasons. But because of that, I'll have to type my password in front of you people, and I do not want to do that. Anyway, so I can go to duck www.duckduckgo.com. And then if I want to know where in the website I want to go, one thing you have to do is click inspect, and that will bring this pop-up. With this pop-up, I can look into different parts of the web page and see the name. So apparently this part is called the search box input, which is like very intuitive, but that's good to know. So by putting things when doing things like this, I can write stuff here programmatically. I'm writing code here, and this code is doing whatever I wanted to do. In cases like this, where I do not know what to click, what I can click, because here the ID is generated in runtime. So in this case, I can't really identify by the ID, but in this case, I'll probably identify by the class instead. Like, but yeah. So if once you know a little bit of HTML, JavaScript, then going through automating tasks in the internet is like very easy. Okay. So is there anything more you want me to explain about Selenium? Opening the WebDriver, but I mean, this is all there is. I If I want to open DuckDuckGo, I'll do. Sorry, if I want to open Firefox, I do driver is equal to webdriver.firefox. Sneezing too often. Like one, of course, reading the Selenium documentation, it might be a little confusing sometimes, but it you can understand it if you read a little. Like Selenium can also do things like opening things in other tabs and things like that. So yeah, moving between windows and frames. Is that fine, Jewelry? Installation of WebDriver. Oh, so it depends on what browsers you have on your computer. Like, I don't like to use Chrome because Google likes to steal our data and things like that. Google, I will accidentally go on a rant about this. Okay, so I I use Firefox for everything. So because Firefox is installed for me, I can do this. If I since if I don't have Fire, like consider, yeah. uh, yeah, so if I do, yeah, so one thing you will have to do, so you must open the installation, sorry, Selenium documentation and download the drivers. I had forgotten that I already downloaded the Firefox drivers because like to I'm right now in campus, and for campus things I need to access internet, I need to run a specific, like open a specific site and do things. So I, instead of doing that manually, I've written a code to do it. So if the moment I run this, it does that thing automatically. So I already had the Firefox drivers installed. I am sorry, I should have I've forgotten about that. So so if you want to automate things on Chrome, you have to download open this link. It will take you here, and depending on your version of Chrome, you should download the right one. Latest Chrome binary, so it is here. Jewelry, you raised your hand. Similarly, if you want the edge, yeah, so without the drivers, you can't do it. Had forgotten that, like, I'd installed the drivers ages ago, so I forgot that these are needed. Like, another reason I don't like Chrome is that it keeps getting updates. So because of that, I keep have to like download new drivers for it. I've installed the Firefox driver like last year, and I'm still using it. So good stuff for Firefox. I've not used the Edge one, but yeah. So yeah, there's that. So once again, like, if you have any issues, you can ask me, of course. But you can if you are stuck on your own, reading the documentation is incredibly helpful. Okay. Now, where was I? Yeah. Okay. So okay. So okay. So the idea right now is we have. I want to like make a maze. So for some simplicity's sake, I'll just first make the maze in text. Wherever there's a wall, I'll put W. That's not readable. Oh my god. One, two, three, four, five, six, seven, eight, nine, 10. I'll start here. Wherever there's a not a wall, I'll put O. This is right now not really a maze, but I just want to see it essentially, right? So in there are it's possible that a string has empty spaces in the front and the back, and I don't want that, so I'm just doing the strip. Maze is equal to maze dot strip. Okay, so one, two, three, four, five. Oh yeah, obviously. Like, sorry, I got confused little why the length of the maze was 54. even though there are just 5 lines. There's a extra character at the end of, there'll be one character here to denote there's a new line. So there's like 10 letters in every row, and one extra letter at the end of each line. So the length of the maze, the length of the string is 54. Now I'll just get the number of rows and columns. So row is equal to length of maze dot split lines, column is equal to length of maze dot split lines of 1 of 0. So Rowan, I hope this part made sense. I've now gotten the number of rows and columns inside a specific thing. Now, okay. So one way I can like draw the maze is using pillow. So I can do, I'll make two kinds of thing. Walk is equal to image dot new. I'll make it actually, because we're drawing a very simple thing, we don't need anything fancy, so I'll just put L. The size of the image, okay, walk will just be one square of the maze. So like one W is one squared. So I'll just give this 50, 50 because that doesn't matter. I'm good. And the color should be 255. So now I have both the walls and the thing. Now I'll make the big image. Maze image is equal to the width of the image is 50 multiplied by the number of columns. The width height of the image is 50 multiplied by number of rows. Give me a second. I really have to sneeze. Okay, so to make this code more nicer to change, I'll just change 50 to a variable. And now I'll I'll read through the image, the picture string, and generate the image. So uh, Oh no. Okay, so paste one. Okay, got the mistake. Oh, someone raised their hand. I have a feeling I swapped my left J and I. Okay, wait. Where's image dot? Oh, it should be. Okay, and finally, so now I have a way I can easily make a new maze. I mean, if you can call this a maze. So I'll just go here and I'll make this O. On changing that, if I now I can I can programmatically generate new mazes by just changing text here, which is like very convenient, right? So we'll first try to, so does anyone want to give their maze, like just to make this code run? By the way, once again, this code will be there in GitHub. So if you want, you can always run this code later on your own. Yeah. So, okay. So while we are going to, if you're going to solve a maze, we have a start position and an end position. Okay. So the start position, we should indicate those on the thing as well. So yes, 21 AI. I'll call you AI. Do you have a question? So I hope this part made sense. How I generated the image using the text. So now what we can do is, okay, we need to think of a way to logically solve a maze. That is, how do I get from this part to this part? So the easiest way will be like every, okay, I'll just take this image. Okay, so can I paste it here? Okay, so oh god, give me a second. Now, okay, photo PS better. Okay, why can't anything just work? Okay, finally. So to say I'm starting here. Is there no tool here which is normal? A paintbrush, a pencil. Okay. Say I st- say I start here. So one thing is you must notice that certain regions are junctions. That is, there are more than two places at two things going there. So this is a junction and this is a junction. Certain places are dead ends. This is a straight up uh, this is a dead end and this is a dead end. In both of these places we have important things to do. So one very simple way to do is we start at start and we move in the directions possible. So from this start I can only go forward. Now I have a choice. I can either take left or right. See, I'm wrong and I take right first. So I'll go right, then go right, and I'll either reach the dead end, a junction, or the end of the map, right? So if I reach a dead end, that means I've gone the wrong way. So I have to go back now. And I must close this part. Since I've closed this part, I can only go here now. So this is no longer a junction. So now I go like this. I go here. I reach this junction, and I once again make a mistake. I go here. I realize it's wrong. I backtrack. I go back to the last place which I know is correct, and I close this part off. And then I just keep going until I reach the end. So, do you guys have any idea any guess how to start coding this? Yeah. Okay. So to make things easier, let's say that we'll give values to all these conditions. Yeah, there are essentially uh, three things essentially. The path we have taken so far, the start, the end, and walls and walkways. So we'll say wall is equal to 0, walkway is equal to 1, start is equal to 2, and end is equal to 3. So instead of looking at a list of strings, it's kind of better to look at a list of a numpy array instead. So we'll first get the numpy array from the list of string. So for we know the number of rows and columns, so we can define the numpy array already. So yeah. So, and now we read the letter, and depending on the letter, we put the value. Which? So, you might have learned of the if condition, obviously. In addition to if, there's a thing called the match condition. Match is essentially like just reading through it. I'll write it first and then you will notice. Uh, oh no, my version of Python is too old for match. Okay, essentially, if you could use match, this is how you'd use it, and you can kind of understand what it's doing. Let is either W, S, E, or O. So instead of writing if let is equal to W, do something, and then else if S is let is equal to S, do something, which is a lot of if statements. Instead of that, you can write it simply like this, which is a very short and sweet way to do it, in my opinion. Unfortunately, let is not here in Python 3.9. I've swapped the ing. Okay, it works. So Now I know the start and end of. I have a maze and I have the start and end. I will add one more, which is I hope most of these variables make sense to you all. Hmm. I guess people. Hmm. Okay, so I'll just keep this here. Now I now that I have this list of array, the thing as an array, I can very easily go from one thing to the other. So given now I personally would write a function to identify what the nearby elements are. So as in which are the legal places I can walk now. Considering people living like this, I'm assuming this is too difficult, but it's a fun problem. Okay, so return is this. I guess people really didn't like the idea of coding a maze solver. Okay, but it's supposed to be amazing, and the YouTube audience will appreciate it, I think. Okay, seeing as there's a distinct lack of interest in this, I guess I'll change something else. Is there any other part you want me to cover? Yeah, that was a little disheartening. Okay, anyways, so if I guess I can just continue writing the maze solver, but I since if no one's asking any questions, I'll just like yeah, okay. So, hello, Raji. I'm right now making a maze solver. The moment I started, everyone left, so that's a little disheartening, but it's fine. Hashtag, right? Right, it's +1. If there are any questions regarding the last weeks of lectures and things like that, feel free to ask. I guess that's more productive than trying to do this. Get legal direction. Oh, oof. I must check for. Hi. So natural, that's correct because the starting point is here. The starting point is here, and up is the only direction we can go, and up is represented by 2. And I feel because concept like this is like very will come very often. I think it will be nice if I make a function for up, down, left, and right. Khalif, do you have a question? Khalif, you have a question?
So may I know what is that? Like which problem is it?
So, I the first half of the class we were looking at PIL and things like that, and I felt like now that we have the knowledge about PIL, we can make a thing which solves a maze. So, so the first thing I did was make a code which draws the maze out, and then I make the code which is going to solve the maze. So from the start, I'll go towards the end. So I do not think we'll have time to complete the this algorithm. So I guess we'll like conclude the class now. Uh, Thank you and have a great week ahead.